Hello everyone, welcome to this video on analytic function. What we are going to see today will be on standard transformations. So we will see what are the transformations of the type translation, magnification, rotation and inversion in this video. Come on, let's move on. We begin with the first type of standard transformation called by the name translation and is given by W is equal to C plus Z. As such, we know that W is going to be represented as the complex number U plus IB, and I have C to be a complex constant. So I can better represent this as say A plus IB, and Z is going to be our usual complex variable X plus IY. So now combining the real part, I have A plus X plus I times B plus Y. Hence, I have my U to be equal to A plus X and I have my B to be equal to B plus Y. Now, what does this transformation do? Say suppose I have an object over here, a square, which is bounded by A, B, C, D. Now this A which is over here will now be moved or whatever be it, like I can give my X to be equal to U minus A and my Y to be equal to B B minus B. Okay, so the new positions of my B minus B. So the new positions of my A will now be at some other point which has been translated over here, and now this will be represented as A dash, B dash, C dash, D dash. So the point P, which was X comma Y in my Z plane, will be mapped onto the point P dash, which is given by A plus X and B plus Y in my W plane. The image in the W plane is the same as that of the image in the Z plane, but it is shifted through a vector called as C. So C is going to be the vector by which the objects get shifted. The two regions are going to be the same in aspects of shape, size, and orientation. So what is the only change we mean to see over here is that of a translation. What does translation mean? A translation means movement. So this object which was in the Z plane is retained in shape, retained in size and retained in orientation, but it has just shifted its position and it has moved to some other space by a vector called as C. So this is going to be the first kind of the standard transformation which we will be seeing. The second type of transformation is given by W is equal to CZ. This is referred as magnification and rotation. Again, you have W is equal to U plus IB. C is going to be the complex constant. So this can be your A plus IB and Z is going to be our X plus IY. So you have the combination of the complex variable to be multiplied with our variable Z. So let us assume this to be in the polar format. That is, let my W be equal to R e power I5, where R represents the modulus of the data and phi represents the amplitude of your complex number. And let Z be represented again in the polar format as R e power I theta, where R represents the modulus and your theta represents the amplitude. And again, we have the complex constant called as C. Let it be represented as A e power I alpha, where A represents the modulus, and our alpha represents the amplitude of the data. Now, what happens when I have this to be equal to W is equal to CZ? I will have R e power I phi to be equal to A e power I alpha into R e power I theta. Now, this being the magnitude or the constant will now become AR e power. This exponential part gets combined as I into theta plus alpha. Now, this portion over here, AR, represents the magnification of the data. So, this R value is magnified as your AR quantity. And what is the second thing which we observe over here is this angle phi or the rotation is now being replaced by theta plus phi. So this is going to be our new rotation which is being presented for us. So when it has a complex number, it does two jobs for us. The first thing, it is going to magnify the data, and the second thing, it is going to rotate the data. In object or the image sense, if we are going to notice it, say suppose we have the object called as A, B, C, D in my Z plane. This transformation of W is equal to CZ is going to magnify the data and rotate the data. So say suppose it is going to be of the format where I have this to be my A dash, B dash, C dash and D dash in my W plane. So what has happened to this square-like structure over here in the Z plane? It has become bigger in size in my W plane. What has happened to the orientation or rotation? It has now shifted and it has just given a rotation to the object, moving it to a different quantity, right? So what is the use of the transformation W equal to CZ? It magnifies the data and it rotates the data. In contrary, if instead of C being a complex number, I have W is equal to AZ, where I have this A to be a real constant. So instead of a complex constant, if I have this A to be a real constant, then what do you think will the effect be? In which case you will have just magnification to take place and there will be no rotation of the image because phi will be entirely absent in our real number systems. So W is equal to AZ. If A is a real constant, causes magnification of the image or the data alone. But if it is a complex constant, it magnifies the data plus also rotates the data. Next, we will move on to the third transformation called as inversion and reflection, which is given by W is equal to 1 by Z. This represents the inversion which is happening with respect to the unit circle mod Z is equal to 1, which is followed by the reflection in the real axis. So, what is happening to mod Z is equal to 1 under the transformation is what we reflect over here. In which case, what happens is the interior points of your unit circle mod Z equal to 1 in my W plane. What is the interior points? These are my interior points. So what will happen to this interior points? Under the transformation W is equal to 1 by Z, they become the exterior points of the unit circle mod z equal to mod, sorry, not z, it will be mod omega equal to 1. So these points which were lying inside the circle will now become the points that lie outside the unit circle. So the mapping just inverts the data and forms a reflection in your real axis. On the contrary, if we are going to have the exterior points of it, of a unit circle, mod z is equal to 1, the exterior points will now, under the transformation w is equal to 1 by z, get converted as the interior points of the circle mod w is equal to 1. So it is just the vice versa way round, where the exterior points turns out to be interior points of your mod omega equal to 1. Primarily, what happens over here is, when I have w equal to 1 by z, my z can be expressed as 1 by w. So this will give me my x plus iy equal to 1 divided by u plus iv. So I can multiply and divide by u minus iv to make this complex constant to be a valid one. So I will have u minus iv divided by a plus b into a minus b gives you a square minus b square. So minus of I square makes it as plus 1. In which case my x can be represented as u divided by u square plus v square, and my y can be represented as minus v divided by u square plus v square. So the reflection of the interior becomes the exterior here, and the reflection of the exterior becomes the interior here. So this is all about the three standard transformations which is given by translation, which causes just movement. Next one is CZ, magnification and rotation. And the third one, inversion and reflection. Thank you.